So now it's time for 7.4, doing operations on radical expressions. So we will talk about adding and subtracting. We'll see what we need as like terms. We'll also talk about multiplying and maybe, let's see, what will we talk about? Just multiplying. We're not going to talk about dividing, just multiplying. So adding and subtracting radical expressions and multiplying. Pretty straightforward. So first of all, before we can add, remember when we're adding things, we always have to have like things. Got this, I don't know, paperweight or trivet thing and a pin. You can't add these together and say you got two somethings. No, it's a pin and a trivet thing. So whenever we add or subtract, for that matter, we need like things. We need things that are similar. So the radicals need to be the same. And the way this works is it's really just 3 plus 5 is 8 square root of 2. Okay, it's like if I had 3 pins in one hand and 5 pins in the other. Where did I go? And I add them together, I now have 8 pins. Same thing the way we think of this. In like terms, I now have 8 square root of 2. Here, they're unlike, so this is all I can say. We're done. Nothing we can do. Okay. So this first one, like terms, right? This is going to be 12 square root of 7. This one, like terms, it's going to be 9 square root of, or cube root of 5. This one, not like, right? Here's a square root of 13. That's all there is to it. That's all you can say. That's the answer. And the same thing down here. Now we got to be careful a little bit. Sometimes these could be reduced, but obviously square root of 16, that could be reduced to, say, 4. So this could be written as square root of 6 plus 4, but that's really all that can be done. They can't be added, so that's what they say. Just don't worry about it. Cannot be added. Okay, write each pair of terms as like radicals if possible. So what we're looking at is there some sort of common? So I see a 25 in here. I see this is, when you see 25, you only, so this is 25, but times 5. So in 25, so this is 5 times, oops, not 2. This becomes 5 times 5 times 5. I see that in there. So I think I could do it as 2 of them can come out. I can rewrite this as 5 square root of 5. So with that in mind, I'm going to see if I can get a square root of 5 out of this. So 5 goes into 80. That's what I'm going to do. 80 divided by 5. I know that's 8. That's going to be 16 times 5. 16, and remember this is really 80 is going to be broken out. 16 square root of 16 is 4. So I think we're going to get this one to be 4 square root of 5. This one's 5 square root of 5. So then we would be able to add them on that basis. Let's check it out. That's exactly what they did. 80, 16, there we go. And 125 is square root of 25 times 5. So we've now got them where we could add them if we needed to. Cube roots. So over here, I know 16 is 2 times 8. 8 is a cube root, so that's going to be cube root of 8. 2 will come out, so I got 4 times 2 on the outside, but a cube root of 2 left inside. So that's probably, to get them to be like, I need to have a cube root of 2 in here. So let's see what happens when I divide 54 by 2. That's half of 54. That'd be 25 plus 2. That's 27. So 27 times 2 is 54. And we recognize that 27 is one of our perfect cube roots. It's 3. So that's going to come out. So we've got 7 times 3 cube root of 2. That's what they're going to get. So we're going to actually have, this one becomes 21 cube root of 2, and this one becomes 8 cube root of 2. But the important part is now they are like terms, so if we needed to add or subtract them, we could do that, right? So they looked at this, 16 is 8 times 2. This is a perfect cube. Boom, take it out. There we are, right? 7 and 54. 54 is 27 times 2. And again, notice I did the sort of the smaller one first and said, okay, if I've got a square root of 2, that's got to be what's left in here. If it's not, it does me no good anyway, right? So, but that's what we end up with. And then 3, and 3 times 7 is 21. Okay, so add these expressions. So notice we look at them, they're not like terms now, but what about the square root of 20? That's 4 times 5, right? This is a square root of 4 times 5. 4 is a perfect square, so that's going to be 2 square root of 5. 5, so that's going to be 7 square root of 5. So first thing is break this down into 4 times 5. There we go. Now it's going to be 7 square root of 5. Over here we got 3. I don't know why, but notice it's a square root of 2 is really what we're looking for. 50 is not too bad to see. That's 25 times 2. Square root of 25 is 5, so that's going to be 5 square root of 2. 72, now again, I know that's 9 times 8, but 72 divided by 2, because I know that's what I'm looking for, 36 times 2. So if you take 72 divided by 2, you get 36, and 36 is 6. Square root of 36 is 6, so we'll have that. So it's 5 plus 6, that's 11, plus 5 more, that's 16 square root of 2. Okay, right? 16 square root of 2. So that's sort of my all over the place looking at it, but part of it is we look, okay, I need this to be the like term, so that's kind of what we're looking. We're looking 50 divided by 2. It gives us a hint. Take 72 divided by 2, and that breaks it down. Oh yeah, that's 36 is a perfect square, so that's going to give us a 6, and that's basically what they do there. Okay, you know what you're looking for, you usually can find it. And then just add it all together and notice their answer answers ours. However you want to do that. Okay. Subtraction, same thing, we need like terms. So this is just 8 minus 2, that's going to be 6 square root of 7. Okay, down here again we have it's not going to help me out here. Oh, there we go. We've got like terms, all three of this. So we got 7 minus 2 is 5 plus 1. Remember, there's sort of that invisible 1. Then we're going to get 6. Put it all together, 6 cube root of 5. Okay, but we need those like terms. We've got the square root here. We can, again, take the square root of 49. That's going to give us 7 square root of 5. We've got like terms. We could also reduce these. Remember, square root of x to the 5th is going to be, you could think of it as x to the 4th times x. This part becomes x squared, square root of x. So you can break it down either before or after. So we've got this, but now they've got a like term here. The thing is once you do that, you need the like term here as well, right? Because you got to have like term. So this is really 1. 7 minus 1 is going to be 6 x squared, square root of x squared. The variable part has to be completely the same. Do the same thing over here, cube root of 64. Again, we might bring up our little paper here. Cube root 64 is going to give us 4. Cube root of 64 will be 4. Okay, so that's a 4 in the bottom. And then we've got common denominators, and we've got the top part that's the same, right? Common denominators, top part. This minus this is going to give us 0. Okay, you take something minus itself. Okay, we just got the multiplication to hit on, and we're good to go for this section. Okay, so this is multiply and simplify. What you're going to need from here is to remember FOIL. So 3 times 5 is 15. 3 times square root of x minus 3 square root of x. Square root of x times 5, that's a plus 5 square root of x. And then square root of x times square root of x, that's going to be actually, oops, I messed it up. It's a plus and a minus. it's going to be minus x, right? Square root of x times square root of x is going to give us just x. They might show the extra step, but these middle terms here are like terms, so we can combine them, 5 minus 3. So we would have as our final answer 15 plus 2 square root of x minus x. Okay, so they do that. They show pretty much the same like we did, except they use blue, and then this guy's got to multiply by those two. So they multiply out. They do show all the steps, but this is x times x. We're going to get square root of x squared, which is just going to be x. These we can combine, and there we go. Same answer. And that's all we have for you for 7.4. So that gets you enough to get started. Remember, during this time period, we do have 2 extra weeks. It's kind of, what are we in our second week now? Anyway, we've got, I think, we've got this week. This is the end of the week for us. This is Wednesday. Next week we've got 2 full classes. We actually, if you'll look, I changed the schedule a little bit. I took out one section, and one night we're going to have 3 sections. So we're actually going to get done even a day earlier. At least I will with the lectures. You still have all that time to work through the problems. Just remember that everything's due by the week that week of May that ends in the May 22nd. That's a Friday. I can go through that Friday for everybody, but let's try to, if you get it done earlier, that's great. I can give you the feedback and we'll go through it. If you need some help on anything, again, just send me an email. Let me know where you're at. If you're, I'll be contacting you all as well, and hopefully hearing back. But just let me know what you need. I'm going to keep moving forward on the videos so that you can, if you want to, maybe speed up or slow down so you can really self-pace yourself through this. Just let me know. I'm available to you. If you need to talk, I'm here. If you need to discuss math, I've got the tablet thing here. We can make it happen. All right, take care, and we'll be in touch.